Hi everybody, welcome to the live stream on your CAT masterclass. This will be the first and we'll be looking at time and speed today. We'll just give it a few minutes for people to join in and we will start in about a minute or two. Yeah, so today specifically we're going to be looking at one particular aspect of time and speed, right? So generally we all know the base formula, right? When it comes to time and speed, that's distance equals speed into time, right? So this is something which is known to everybody, right? So now what beyond it, right? So what beyond it? Now typically the school method, right? So we tend to use variables, right? So wherever possible we are told to adopt a variable, let speed be x or time be x and so on and so forth, and we try to solve it. But in today's class specifically we're going to use a technique which is nothing but utilization of ratios over here to solve it. Now while using ratios, we'll see that how to solve these questions without using variables and very quickly, just understanding the base logic of it and the score formula of distance equals speed into time, and that's about it, right? These are all CAT questions. We're specifically going to be looking at one particular paper, CAT 2020, right? Across the 3 slots, picked about 6 questions over here to look at. And in these 6 questions, we'll see as to how we can apply ratios and right away solve it, and without utilizing any variables or minimal use of variables, right? So that's going to be the key. Yeah. So I think all of you know the base formula, as I said, right? So once again, distance equals speed into time, right? So that's the base for time, speed, and distance. Now, where do we bring in ratios over here? All right, so ratios is coming in from a very simple concept over here. Look at it this way, right? So let's say the ratio of speed, right, for 3 people, A, B, and C, are given us some values, right? Let's take it as S1, S2, and S3, right? So this is going to be the ratio, or rather, let's just bring in some values over here, right? Might even become better, right? So let's just say the ratio over here is going to be 2:3:4. Now, if the ratio of time is given to us as well, right? So let's say that is 1:2:3. Then very simply put, right? Very simply put, if speed into time equals distance, right? If speed into time equals distance, and that's what's given over here. If ratio of speed and ratio of time are given to us, then all we need to do is we need to multiply the respective parts. For A over here, 2 into 1 is going to be 2. 3 into 2 over here is going to be 6. 4 into 3 over here is going to be 12. 2:6:12 is going to be the ratio of the distance covered by the 3 of them. So which is nothing but 1:3 over here is to 6, right? So you can just divide all of them by 2 and you're going to get 1:3:6. That's the ratio of distance covered. Now, why does it work this way? Some of you might be wondering, right? So what we've been taught in school is when you have ratio of speeds given, the actual values we can assume as 2s, 3s, and 4s, right? These would become the actual values. Likewise, if ratio of time is given as 1:2:3, we can take the actual values as 1t, 2t, and 3t, right? We can link up. If a ratio is given, we can just use one variable over there. Now, when you multiply these, right, to find the distance covered, if the actual speed is 2s, actual time covered is 1t, then the actual distance covered is going to be 2st, right? I've just written ratios over here, but here we are working with actuals because I've used a variable, right? So 3s into 2t is going to give us 6 into st, and here it's going to be 12st. But once again, we're not concerned about the actual figures, it's the ratios we are concerned about. So what happens to the variable of st over here? It's common for all of them and it gets cancelled, and therefore, right, when it comes to ratios, as we've seen in the ratios lesson in Mockat.com, what you need to do over here is just multiply the respective parts over here and you're going to get the ratio of distance covered, right? So simply put, once again, so if you have A and B only, right, this time let's just take A and B. Once again, distance equals speed into time over here. If the ratio of distance covered, let's say, is given to us as 3:2, yeah, and let's say the ratio of speed over here is given to us as 1:5, right? Then what is going to be the ratio of time taken? Now this time around, for time taken, right, it's going to be distance by speed, right? Distance by speed. So what are we going to get over here? Time taken is distance by speed. So once again, it's division over here, right? So 3 by 1 over here. And on this side, what I'm going to do is 2 by 5. Now, the beauty with ratio of two terms only, right? Ratio of two terms only, if they are in fractions, what we can do is we can cross multiply and write it down. So 5 3s are 15 is to 2, right? So 15 is to 2 over here is going to be the time taken, right? So ratio of the time taken for A and B. Now this over here, this cross multiplication you cannot do. We've seen the ratios lesson if there's going to be a third person involved, right? So let's say for this case we had one more person over here and we got 1 by 2, right? Distance over here, ratio of distance was 3 is 2 is to 1, ratio of speed was 1 is to 5 is to 2, and this was the time taken. Now what would have been, you simply could not have cross multiplied because we have 3 terms here. So what we need to do in this kind of a scenario, if there are more than 2 terms involved, right, in the ratio is to multiply the entire thing with the LCM of the denominator. LCM of denominator 1, 5 and 2 is 10, right? Each term if you're going to multiply with 10, what's happening is we're getting rid of the denominator. 3 into 10 is 30, 2 by 5 into 10 is 2 into 2 which is 4, and then half into 10 over here is going to give us 5, right? So all of you clear with this here? So 30 is to 4 is to 5 is going to be the ratio of the time taken if the ratio of distance is given as this and ratio of speed is given as this. Yeah, fine with this, all of you? Just a yes or no on the chat, that'll help. Okay, right. Okay. Okay, so let's move on to the next part over here, right? So once again, we start with our base formula, which is distance equals speed into time taken. Yeah, all of you. Hey, you guys can just type into the chat now if you have any doubts at any point over here. I can explain that part again, right? Just a quick yes, no on the chat. If you're able to hear this clearly. Yes or no, yeah? Okay. All right. So now distance equals speed into time, as I said, right? So what we have over here is the part where one of them is going to be the same or constant, right? Now, if distance is given to be the same, let's say A and B are going from their home to, from points A to B, right? Let's say A and B over here are two people, right, who are going from point P to point Q, right? That's a fixed distance over here. Now, distance is going to be the constant, right, from one place to the other. Yeah. So what happens over here, right, for A and B, the ratio of distance covered is going to be 1:1, right? If let us say the ratio of speed is given to us, right? So let us give some speeds over here. Let us say it's going to be 7 kilometers per hour for B and 8 kilometers per hour for A over here, right? So what is the ratio of speed? It's going to be 8:7. Yeah. Now, if we are told, right? So if you're going to be told that A, who's the faster person, is going to reach first. A reached 5 minutes before B. Yeah. So A reached 5 minutes before B. Then how long did B take to reach, right? So if this is going to be the question, now how do we solve this? Simply without using a variable over here, right? So when the ratio of distance covered is going to be distance covered is the same, or ratio of distance is 1:1, ratio of speed is 8:7, then the ratio of time taken is simply the reciprocal of the ratio of speed, right? Because once again, if you want to apply the formula over here, distance by speed is time, so 1/8 is to 1 by 7 is what you're going to get. Going forward, you don't even need to write this down this way, right? Where the ratio of distance covered is 1 is to 1, or rather the distance covered is the same, it's constant, then ratio of speed is going to be the reciprocal of the ratio of time taken, or the other way around. Ratio of time taken will be the reciprocal of the individual parts of the ratio of speed. So ratio of speed is 8 is to 7. The ratio of time taken will be 1 by 8 is to 1 by 7. But when there are only two terms, you can simply switch this way as 7 is to 8, right? So now that we found that the ratio of time taken is 7 is to 8 over here, right? Now it makes our life easy, because it's given over here that A reached 5 minutes before B, right? So that means the difference in the time taken by them is 5 minutes. So what you can quickly do is write a difference over here, right? When A covered 7 parts, right, 7 units of time, B took 8 units of time. The difference is going to be 1 unit in ratio terms. Now in absolute value terms, in actual terms, we need to find out, and what would that be, right? In actual terms, I know that one part over here is 5 minutes, right? So 1 unit is 5 minutes. Then how long did B take? B took 8 units, right? If 1 unit is 5 minutes, 8 units over here is 8 into 5, which is 40 minutes, and there we get the answer, right? So therefore, if you know the ratio over here, right, of the distance covered, or and ratio of speed over here, ratio of time taken is going to be simply 1 divided by the other, and the other way around, right? So without wasting further time, let's put it to use, right? So let's start off with the first question, right? We'll set about 3 minutes for each question over here, right, for you to solve it, right? So 3 minutes to go. This is a CAT 2020 slot 1 question, right? Just try to apply the same. Yeah, just take your time on this, don't hurry in, right? Let's see. Okay, right. So let's look at solving this now, right? So leaving home at the same time, right? So Amal reaches office at 10:15 a.m. Now if he travels at 8 kilometers per hour and at 9:40 a.m., right? So what is happening over here? Okay, sorry, just read this part again. Leaving home at the same time, Amal reaches office at 10:15 a.m. if he travels at 8 kilometers per hour, right? And at 9:40 a.m. if he travels at 15 kilometers per hour. At the start itself, there are two scenarios given to us, right? So there's a scenario 1 over here, right? And a scenario 2, right? Just write it down. And what are these two scenarios over here? One is for 8 kilometers per hour speed. That's an absolute value which is given to us. And a 15 kilometers per hour speed, which is also given to us. So we can just write it down over here. Once again, we're going to be looking at ratios. So the unit over here doesn't really matter at this moment, right? So one is 8 and the other is 15. Yeah. And the ratio as well, if you want to write down ratio of speed, that's going to be 8:15 itself. Now, if we know the ratio of speed is going to be 8:15, we can immediately say that the ratio of time over here is going to be the reciprocal of this, which is 15:8. Yeah. So if the reciprocal is 15:8, and we have found that the ratio of time now, right? What is given to us? In one scenario, right, the person reached at 10:15 a.m., the other scenario at 9:40 a.m., but in both the scenarios, the person left at the same time, right? So in the second scenario, a person is reaching sooner, right? How many minutes sooner? 10:15 a.m. minus 9:40 a.m. and that's 35 minutes sooner, right? So difference in time taken is going to be 35 minutes. Now the beauty with ratios is the difference over here, you can just find the difference in parts over here, right? The time difference, you can just write it as difference over here. 15 minus 8 is going to be 7. And this 7 pertains to actual minutes of 35 minutes. You can just write actual time over here for your reference, right? Once again, so far, we haven't used any variables. So if 7 units is 35 minutes, then one part or one unit is going to be 5 minutes, 35 by 7, right? So ratios, if 7 parts pertain to 35 minutes, one part pertains to 5 minutes, 8 parts pertains to 8 into 5, 40 minutes, right? Now, this is something if you can relate to, you'll be able to immediately get. Another way to do this, right, foolproof, for you to always get it without using a variable, right, is going to be, we have 4 parts over here, right? So we have 8 and 7 in relative terms. We have an actual of 35. This we don't know, right? This we don't know, which is x. So what we've seen in the proportion lesson is, what you don't know over here, if you want to directly get it without using a variable, the product of the known diagonal, 8 into 35, divided by the opposite value of 7, and that's it. You simplify over here, you'd get 8 into 5, which is 40 again, right? Now this is for your early days, right, if you're going to be trying it, but eventually what I want you to do is, if 7 parts is 35 minutes, 1 part is 5 minutes, 8 parts is 40 minutes, which means the person who's reaching at 9:40 a.m. over here left at 9 a.m., right? Travel for 40 minutes only, right? Okay, now what is given over here? Leaving home at 9:10 a.m. At what speed in kilometers per hour must he travel so as to reach exactly, office exactly at 10 a.m.? You leave at 9:10, you reach at 10 a.m. You're traveling exactly for 50 minutes over here, right? Now, there's a scenario 3 which is brought in, right? In scenario 3, the person has to travel for exactly 50 minutes. In scenario 2, it was 40 minutes. Now, the other way around is given to us. Now, I can find the ratio of time for scenario 2 and 3. 40:50 is 4:5. Then what is the ratio of speed over here? It's simply 5:4, right? We're working the other way around. Now, do we know the actual speed for scenario 2? Yes, it's given to us over here, which is 15 kilometers per hour, right? 9:40 a.m. if he travels at 15 kilometers per hour. So scenario 2 speed we had noted over here was 15. If 5 parts is going to be 15, 1 part is 3, 4 parts is going to be 12, right? And therefore 12 kilometers per hour is going to be the answer for this question, right? So if you're going to be using, ratios over here, right? So it's going to be very simple, minimal calculations, scope for making errors again very low, and the best part is no use of variables. So you're going to be pretty quick as well. Initially you might find it a little tough, but as you practice more, right, in these terms, you're going to be seeing that you would be able to solve a lot of these questions mentally as well, right, without even putting pen to paper. Yeah. Okay. So that having said, any doubts on this? Yeah, just feel free to ask. Right. Okay. So a couple of you had gotten 14, right? But the answer is 12 over here. Yeah. I think the mistake which you might have made is you wouldn't have noted that leaving at 10 a.m., 9, 10 a.m. the second case, I mean the last case, scenario 3, right? You got to be wary about these. Okay, so let's move to the next question, yeah, both of you. Let's move to the next question over here. Okay, how do you go for this? Again, CAT 2020 paper. We'll reset your timer over here. Okay, 3 minutes to go. This is actually a simple question, right? It's quite a simple question. Okay. Okay, so for this one, I think quite a few of you have gotten the answer right, So on the chat, that's good. That's good. So simple concept over here, right? Simple concept. This is like your races, right? So A beats B by so many meters and so on and so forth, right? So all we need to do is first off to draw the track, right? So draw the track and get a sense of it, right? And get a sense of it. So let's draw two of them because we have two scenarios given to us over here, right? Let's start with the first one, right? So where A is completing the race. A is beating B by 45 kilometers. What does that mean, right? So when A completes the race, B is 45 kilometers behind A, right? So that's what it means. Now, B beats C by 50 kilometers. That's a different scenario. If car B is beating C by 50 kilometers, it means when B completes the race, C over here is going to be 50 kilometers behind B. Yeah. And another scenario is given. Car A is beating C by 90 kilometers. That's nothing but the first one. If car A is beating car C, that means when car A completes, C is 90 kilometers behind. B is 45 behind. C is going to be another 45 kilometers behind, right? So that the total distance over here between A and C is going to be 90, right? A and C over here is going to be 90. That's it. The first sentence over here gives everything. The distance in kilometers over which the race has been conducted is what, right? Now, once again, How do we do this? Without the use of variables, right? So in this question, what we have over here is the time taken is constant, right? So as we've seen in the time and speed lesson again and again, right? So where time is constant, we can just work with a simple relationship. Once again, distance equals speed into time. If time taken over here is held constant, we have an equal to over here. So therefore, the ratio of distance covered is going to be the ratio of speed. That's it, equal to over here, and that's it. So ratio of distance equals ratio of speed. Okay, so now coming back to a case over here, right? So how do we incorporate that over here, right? So what you need to notice, the first scenario over here, which is drawn over here, has happened first. A reached, and then B is reaching the finish line, right? So when B reaches the finish line, C is moving from this position to over here, right? The time taken is the same for B reaching the finish line and C moving from here to here, because these are two snapshots in time given to you, right? Two snapshots. What are the snapshots? A is completed. Next snapshot is when B is completed. Where is C, right? So immediately for B and C, what we can do is we can write it down. What is the distance covered by B and C, or rather the ratio of distance covered, right? Now what is happening over here? When B is completing 45 kilometers, right? 45 kilometers, C, who was 90 kilometers behind, right? Behind the finish line, C, who was 90 kilometers behind the finish line, is now only 50 kilometers behind the finish line. That means C has covered 90 minus the remaining 50, which is 40 kilometers. C has covered 40 over here. So the ratio of the distance covered should be equal to the ratio of speed, right? That's what we have seen, because the time taken is the same, right? Within a specific amount of time, when B is covering 45 kilometers, C is covering 40 kilometers. So ratio of speed is going to be 45 to 40, or 9 is to 8. Yeah. So 9 is to 8 is the ratio of speed, but I also know that that's the ratio of distance covered. Now what is asked is, what is the length of the entire track, right? What we can see over here is, when B is completing the race, C is 50 kilometers behind. So when B is completing the race, if I say B is covering 9 parts and completing the race, C has covered only 8 parts. How many parts behind is C? That is the difference, right? Once again, we can apply the difference concept. 9 minus 8, which is 1, is the difference in parts. Yeah. Once again, no variable usage, right? So 9 minus 8 is 1. This difference in part is this 50 kilometers over here, right? If one part is 50 kilometers, B has covered 9 parts and completed the race. That's going to be 9 into 50, which is a total of 450 kilometers. And therefore, option 1 is the answer over here. Yeah. So once again, as we've seen in the lesson, and if you're able to apply this concept, right, with practice, you're going to be getting it sooner, right? And those of you who already have it, that's good, right? So once again, very briefly, what you need to do over here is 45 and 40, right? Identify that, or rather, even before that, we need to see as to what is held constant over here. Distance equals speed into time. I know that time can be held constant, right? Time is held constant because two scenarios, right, in time. What are they? A is completing the race, and the next is when B is completing the race. Between these two, there is a constant amount of time. In that constant amount of time, B is covering 45 kilometers and C is covering 40 kilometers, right? So therefore, when time is held constant, the ratio of distance covered 45 to 40 is 9 is to 8, right? Once you have found the ratio of speed, 9 is to 8, we have just seen that it's the same as the ratio of distance covered as well. Now, when B is completing the entire race, right, C is 50 kilometers behind. So difference in distance covered of one part should be of 50 kilometers. And with this, you'd be getting B is at 450 kilometers. C over here, if you want, you can write at 400 kilometers, right? So that's going to be 400 plus the 50. That's 450 in total. Yeah. Okay. Any doubts? Again, please feel free. You can just write them. I think all of you got the answer right for this. Yeah. Those of you who typed into the chat. That's good. Let's move on to the next question. Right. Good. Yeah. Good stuff on this. Once again, 3 minutes to go for this. Okay, right. So I think, yeah, so quite a bit of you have gotten the answer, right? So typing into the chat as well. That's right. Okay, that's good, yeah. That's good, that's good. So the flow is good. I think you're using the ratios concept well. This was, I mean, slightly tricky, right? So there are a couple of components which you need to integrate. Once again, as I've said, the theme today is to not use variables and go completely with ratios, right? Let's see as to how we can do this. Wimla starts for office every day at 9 a.m. and reaches exactly on time if she drives at her usual speed of 40 kilometers per hour, right? So what's given over here is a usual speed. Quickly we can make note of it and say 40 kilometers per hour. That's the speed over here. Okay. Now she's late by 6 minutes if she drives at 35 kilometers per hour. Okay. There's a second scenario. So let's call it scenario 2, right? Don't want to mix it up. We'll just call it scenario 2, and that's at a speed of 35 kilometers per hour. So ratio of speed over here is nothing but 40 is to 35, which is 8 is to, right? 8 is to 7. Okay. Now, what is the ratio of time taken, right? So here once again, the distance is constant, right? From home to office, the distance is constant. So if distance is constant, speed and time have a reciprocal relationship. Distance equals speed into time. If distance is held constant, right? So this is constant. Both of these are on the same side, right? So they have a reciprocal relationship. So therefore, the ratio of time taken over here is simply going to be 7:8, right? That's the beauty with the ratio of two terms. So if it's 8:7, then the reciprocal is 7:8. You can just flip it. If there are going to be three terms, we have to find the reciprocals for each of them and then multiply with the LCM of the denominators. We don't need to do it over here, right? Okay, so we know 7:8, and what else do we know? She is late by 6 minutes. We have to utilize this somewhere, right? 6 minutes is the, in actual terms. Very often, right, what's turning up in these questions? We are given the difference, time difference. If you're late by 6 minutes, compared to a usual scenario, you're taking 6 minutes longer, right? In terms of ratio, it's 1 part more, 7:8. 8 over here is 1 part more than 7. Now, if this 1 part is nothing but 6 minutes, and that's it, 7 parts over here is going to be 42 minutes. So usual time taken is going to be 42 minutes. Scenario 2 over here was 8 into 6, which is 48 minutes, right? Once again, no use of variables. Let's continue now. Now, one day she covers 2/3 of her distance to office in 1/3 of her usual time. Okay, usual time is 42 minutes, right? So we'll write down a, let me just write down a scenario 3 over here, right? What has happened over here? Scenario 3, she has covered 2/3 of her distance to office in 1/3 of her usual time. 1/3 of usual time is 42 minutes by 3, which is going to be 14 minutes. She covered in 14 minutes, time taken over here. Yeah. And then stops for 8 minutes. She stopped for 8 more minutes. So total time taken is going to be 22 minutes for 2/3 of the journey, right? For 2/3 of the journey is has taken her 22 minutes, right? That's what is given over here. The speed in kilometers per hour at which she should drive the remaining distance to reach office exactly on time. Now, for you to reach office exactly on time, right? 42 minutes is the total time taken, usual time. You've already taken 22 minutes. You should cover the rest of the journey in 20 minutes. Yeah. The rest of the journey over here should be covered in 20 minutes. Now, let's compare that with the usual scenario. What is the rest of the journey, right? 1/3 of the journey, 1/3 of the journey. The time taken over here for the last 1/3 should be 20 minutes in this scenario. But under the usual scenario, what is the time taken? For 1/3 of the journey, it's going to take 1/3 of 42 minutes, which is 14 minutes, right? So once again, we have time given. We know the speed, right, in the usual scenario. We have to find the speed in this particular scenario, right? This particular scenario over here. And it's as simple as that. Now, once again, the last 1/3, the distance is going to be the same, right? It's 1/3 of the journey or 1/3 of the distance. So if the distance is constant, speed and time have a reciprocal relationship, okay? So let me just write it down over here, all right? I'll just continue over here. So usual and scenario 3, I'm just continuing over here because of space constraints. So if it's going to be 14 and 20 minutes, ratio of time taken is nothing but 7:10. The ratio of speed over here is nothing but 10:7, reciprocal relationship. if 10 parts over here was nothing but 40 kilometers per hour, if 10 parts was 40 kilometers per hour, then 7 parts is going to be what? Right? 10 parts is 40, 1 part is 4, 7 parts is going to be 7 into 4, 28 kilometers per hour. Option 4 over here is the answer. Yeah, all of you clear with this? Yeah, right. So this kind of a question, once again, we managed to do it without the use of variables and minimal steps, right? What helps is a tabular or a tabular structure over here, right? And clearly writing down the different scenarios, linking them up with the ratios, right? And that will get you to the answer very, very quickly. Yeah. Okay. So we'll look at the next one now. Yeah, all of you. Once again, I'll give you 3 minutes. Yeah, 3 minutes over here. Start. And at any point, if any of you have any doubt, just feel free to ask once again. Generally will be a bit of a lag in the recorded sessions, the live streaming and all of that. So just feel free to voice out even if you feel that I've moved on to something else, and I'll be happy to explain. Yeah. Now this is a question which you can actually solve in about 1.5 minutes max, right? Shouldn't take you too long over here. Already quite a few of you with the right answer on the chat. Okay, good. Stop the time here. Right. So how do we do this? Right. So what do we have over here? Anil, Sunil, and Ravi run along a circular path of length 3 kilometers. Again, there's a separate section for this, right? Circular track. We have it in the lessons. But you don't need to necessarily go through it to answer this, and we'll see why, right? So if you're able to logically look at it, you'll get the answer. But if you've gone through that portion of my lesson over there in mockat.com, you'll see that, be able to get it. It's a straightforward application of the concepts, right? So nevertheless, so how do we do it? Using ratios over here, right? So what do we have here? Anil, Sunil, and Ravi, right? So A, S, and R, right? The three of them are running along a circular path of length 3 kilometers. Okay, 3 kilometers over here. I will just write it down just for a reference perspective, right? Around it is going to be 3 kilometers. Now they're starting from the same point at the same time, so let this be the starting point. All right, just tidy it up a bit over here. Okay, starting from there. and going in the clockwise direction, right? So all of them, fine. If they run at speeds of 15, 10 and 8 kilometers per hour, 15, 10 and 8, all right, I'm just going to write it down, the speeds over here, right? How much distance in kilometers will Ravi have run? How much distance would Ravi have run when Anil and Sunil meet again for the first time at the starting point? Okay, a lot of it given over here. So when this happens, what is this happening? Anil and Sunil are meeting again for the first time at the starting point. Who's the faster person over here, right? So Anil or Sunil? Anil is at 15 kilometers per hour, is the faster person. Anil would meet Sunil at the starting point when they complete an integral number of laps, right? A full lap of sorts. So let's look at it, right? So speed over here, right? So what is the ratio of speed? Let's first write it down, then we'll understand. 15 is to 10 over here, which is nothing but 3 is to 2. Now, time taken is the same, right? Why am I saying that? They start running at the same time, and then, well, once again, stop the watch and I'll check as to, you know, how much have they covered distance. It will remain in the same ratio of speed, right? Ratio of distance will be equal to ratio of speed if the time taken is the same, right? Start time is the same, then I'll say stop and I'll check, and they've covered the distance as well in the same ratio as that of the speed. Now, as we are speaking about, you know, meeting at the starting point again, when will a person come back to the starting point? When the person has completed a full lap, right? You start, you complete a full lap, and you're back to the starting point. So I want to look at it in terms of an integral or integer number of laps. So what we need to do is reduce the ratio to the smallest terms possible and keep them in integers. And we have it as 3:2. Perfect. Next step is very simple. When this person covers 2 laps, right? A over here would have covered 3 laps, right? When S over here has covered 2 full laps, A has covered 3 full laps, and that means both of them are going to be at the starting point, right? That is the first time when S covers 2 laps and A covers 3 laps, both of them are meeting at the starting point, and that's it, right? So with that, we'll be able to find out the distance covered by them, right? Distance covered is nothing but 1 lap distance is given as 3 kilometers. For 2 laps, it's going to be 6 kilometers. And 3 laps, we don't need it, right? So 3 into 3, if you want, you can write it down, 9 kilometers. And if you want to know the time taken, it's going to be the same in both cases, right? 6 by 10, right? Or in this case, it's going to be 9 by 15, right? In both cases, if you simplify, you're going to be getting 3 by 5 hours, right? It's going to be the same, will have to be equal, right? Because time taken is the same, right? That's what is the question. So we can just take either of them. We'll just take 6 by 10 hours, right? The question asked is, in this time of 6 by 10 hours, how much distance is R covered? What is R's distance covered? That's simply the time taken into the speed of R, which is 8 over here. I'm just taking 10 over here because it's easy to divide. 6 into 8 is 48. 48 by 10, we know, is 4.8, right? This would have been in kilometers per hour, right? And distance covered is nothing but in kilometers. And that's it. That's our answer over here. Option 1 is the correct answer, right? So quite a bit of you got the answer right, which is good, right? Simple concept over here, which was both of them are meeting at the starting point once again. That is on full completion of laps, right? Both of them should have had full completion of laps. If the ratio of speed is 3:2, then for the first time they would meet when 2 laps are covered by S and 3 laps are covered by A, right? That's when they meet for the first time together at the starting point, right? At the starting point. And with that, you get the answer, right? So any doubts here, all of you, you can just voice out, you can just type into the chat, you can take it up. Otherwise, right? So we can just move on to the next question. Now, the next 2 questions are from 2 different slots of the same paper, CAT 2020, for which we will be using ratios once again. But there's a very simple concept which we have covered in the one of the shortcuts or conceptual parts you can look at, right? You can call it a shortcut as well, right? So we've seen that in the lesson. That pertains to this, right? A simple thing, right? Let me just draw a line over here, okay? Now, let's say there are 2 people over here, all right? So A is coming from this point and B is coming from here, okay? And we have P and Q. Now, let us say they're going to be meeting somewhere over here. Yeah, so they're going to be meeting, and this is their meeting point. Now, after they meet over here, both of them are starting simultaneously and they meet at this point. Now, after meeting, if A is going to take, right, so A is going to take another 10 minutes to reach the destination, right, which is Q, and if B after this meeting point is going to take, let's say 40 minutes, yeah, so 40 minutes over here to reach this point, yeah, then how long did they take to meet over here, right? So how long did they take to meet? And here we can use some variables over here and prove it, and we've seen that in the lesson, right? Don't want to restate it over here, but then the shortcut over here is this, right? So the derivation is given to you. The time taken to meet, right? So time taken to meet is going to be the square root of the product of the additional time taken by each of them to meet to reach their respective destinations, right? So root of 10 into 40, right? That's going to be root of 400, and root of 400 is nothing but 20 minutes, right? If it is given to you that A and B start simultaneously from two ends and they're heading towards the other person's origin, and they take a certain amount of minutes to meet, right? Now after meeting, A takes 10 more minutes and B takes 40 more minutes to reach the respective destinations. The time taken to meet, right? Time taken to meet is going to be root of 10 into 40. That's going to be root of 400 over here. Root of 400 is 20. 20 square is 400. 20 minutes is what it takes. Now with this, what can we say? We can say the total time taken by A and B, right? So what's the total time taken? Total time over here is nothing but took 10 minutes longer after taking 20 minutes to meet. So total time is 30 minutes over here. And what about this person? After 20 minutes took 40 minutes more, right? So 20 plus 40 over there is going to be 60 minutes, right? So total time taken was 20 minutes and 60 minutes by, 30 minutes and 60 minutes by A and B to reach their respective destinations. Once again, so if you just know the extra time taken, you can just apply this. This is given to you in the lesson. The same concept was used in two different slots and two different questions. And we look at both of them now, right, for the rest of this session. Okay, so without further time, okay, let's start with this. All of you, 3 minutes to go. You don't need 3 minutes. 3 minutes is more than enough, right? Once again, to give you a perspective, if you're able to solve a question in 3 minutes, right, you're able to, in 40-minute paper it is right now, right? 60-minute paper, you're going to be finishing 20 questions correctly, right? If it's all correct, once again, 40 minutes, you should be able to get about 13 questions. If they're all right, you're targeting 99 plus percentile for sure. In most cases, it's going to be 9.5 plus percentile, right? So therefore, 3 minutes over here is very, very good time for you to solve these questions. And you'll see that, if you're going to be applying ratios, you'll be able to solve it a lot quicker. Yeah, just give it a go with this. I think it's more than enough time. Yeah, most of you, a lot of you have gotten it right. Yeah, very simple question. Once you know the concept of the shortcut over here. Yeah. Okay. Let me reset the time over here. Yeah. Okay. So how do we do this? Quite simple. You don't need to draw anything over here, right? So the moment you understood the concept, in case you didn't, just rewind a bit and you'll understand it. A and B are 2 points on a straight line. Yeah. So in case you wish, you can just draw it down. Ram is running from A, right? Ram is going from A, and Rahim over here is running from B, right? So okay. So what's given over here? After crossing each other, Ram and Rahim reach their destinations in 1 minute and 4 minutes respectively. After crossing each other, after the meeting point, Ram is taking 1 minute extra, Rahim is taking 4 minutes extra. So the time taken to meet, right, is simply the root of 1 into 4. That's it. Whatever was extra taken. And root of 4 is nothing but 2 minutes extra. 2 minutes, right? So 2 minutes is all it took to meet. Now what is asked is, if they start at the same time, then the ratio of Ram speed to Rahim speed, right? Ram speed to Rahim's speed over here, we need to find the ratio. Now ratio of two terms can be written as a fraction, right? So therefore it's given this way. Okay, so we know the time taken, right? So what's the time taken over here? Time taken by Ram to meet is 2 minutes. After meeting takes 1 minute extra, 2 plus 1 is 3 minutes. Rahim over here, time taken to meet is 2 minutes, and after that is taking 4 minutes extra, so 2 plus 4 is 6. 3 is to 6 over here is nothing but 1 is to 2 in terms of ratio of time taken. Ratio of time taken is 1 is to 2. Ratio of speed, right, where distance is constant, ratio of speed over here is reciprocal of the time taken, right, ratio of reciprocal of time taken, and that's for two terms is simply flip it, 2 is to 1. That's it. So ratio of speed is 2 is to 1, all right. Ram speed to Rahim speed as a fraction is 2 by 1 or simply 2. So option 3 over here is the answer. As simple as that. Once again, no use for variables. Yeah. So just practice this, guys, right? So a lot of people have seen that, right? So you start applying the school concept. It was there for a reason, right? In school, you can't be having workings like this. The teacher who's evaluating won't understand whether you understood the logic or not, right? So therefore, they needed steps. They needed you to use variables or give detailed explanations of these in terms of steps so that they understand that you understood the right way, and then you got marks. You used to get step marks as well. But now with CAT, there's nobody sitting over there and evaluating or seeing as to how you understood it. This is more of, within the stipulated time, get the answer as quick as possible. That's what they want you to do. They don't care about your steps. So it's quite away, quite different from your school approach. No more steps, no more step marks, no more writing in length. You don't need to use variables. Get the answer as quick as possible. Ratios method is the way forward, right? A lot of time and speed questions. If you want me to quantify, I would say at least 2/3 or about 80% of time and speed questions you'd be able to solve using ratios, right? Very quickly at CAT level, ZAT level, and all of that. Okay, so let's move to the last question for the day. Once again, a lot of you got the answer right, which is good, right? Last question for the day. And what do we have over here, right? Similar concept as I said, right? Start the timer here. Similar concept you need to apply. This was from a different slot of the same year, same paper, right? So you're going to have similar questions, but you can't be repeating the same exactly, right? Slightly different it's going to be. Just give it a shot, all of you. 3 minutes is ample time. You don't need it, but yeah, early days, let it be. That's the that's the beauty with these questions, right? So it's not going to take you 3 minutes, yeah. And at 3 minutes, if you're able to solve on average, you're hitting 99 plus percentile in this section for sure. You need to pick and choose the questions. These are the questions you need to pick and choose and go for. Yeah. Okay. Already people with the right answer. It's good. Right. Correct. So far. Good. Yeah, I think I can just pause at this. Yeah. More than enough time. Right. So more than enough time. Right, so let's look at it, yeah. So straight road connects points A and B. Car 1 is traveling from A to B, right? For the heck of it, just draw something like this, right? Freehand, it's okay. So A over here and B. Car 1, right, traveling this way, and car 2 over here, okay? Traveling from B to A, both leaving at the same time. At the same time they leave. After meeting each other, once again, after they meet, they take 45 minutes and 20 minutes more to complete the journey respectively, okay? So the time taken to meet, what's that going to be? We've seen that direct formula, root of 45 into 20, right? 45 into 20 is nothing but 900. Root of 900, right? 900 is 30 square, so 30 over here. So 30 minutes is what it takes to meet, yeah? So A and B, right? What is the time taken? That I know over here. Now A over here took 30 minutes to first meet B and then took 45 minutes extra. So 30 plus 45, 75 minutes is the time taken over here. And what about B? After meeting in 30 minutes, took 20 minutes longer. 30 plus 20, that is 50 minutes over here. When I know the absolute time taken, I can quickly find the ratio of the time taken, right? What's the ratio of the time taken over here? It's 3 is to 2, right? 75 is to 50 is 3 is to 2. Ratio of speed, right? Beauty as it is, distance is the same for both the cars to be covered, AB. So therefore, speed over here is nothing but the ratio of the reciprocal of the time taken. The ratio of speed is, so I don't need to do 1 by 3 is to 1 by 2. I can just write it as 2 is to 3 because ratio of two terms as we have seen. So if ratio of speed is 2 is to 3 now, right? So what can I say? What's given over here is car 1 is traveling at the speed of 60 kilometers per hour. Right, sorry, these were not A and B, these were car 1 and car 2, right? Okay, car 1 and car 2. Car 1 was traveling at 60 kilometers per hour. If two parts over here pertain to 60 kilometers per hour, right? What is three parts going to pertain to? Two parts are 60, one part is 30, half of 60, 30. Three parts is 3 times 30, which is 90. 60 is to 90 is 2 is to 3. Or what you can always do is, as I said, cross multiply the known diagonal. The known diagonal just multiply 60 into 3 divided by the opposite value, which is 2. And that's it. You simplify and you're going to get 90 kilometers per hour once again. And you get option 4 as the answer. This part you can apply when working with these is going to be difficult, right? So if these are going to be simple, two parts is 60, one part is 30, three parts is going to be 90. Right? Try to do a lot of these questions mentally. If you're really looking to crack this paper, right? A lot of these questions you have to try to do mentally, even without pen and paper. These are questions you can definitely do, right? So just to give you an example, just wipe off everything. What do we have over here? After meeting each other, it take 45 and 20 minutes. Root of 900 is 30 minutes, 30 to meet, right? 30 to meet, 30 plus 45, 75 for A, 30 plus 20, 50 for B. For car 1 and car 2, time taken. 75 is to 50 is the time taken, ratio of time taken, 3 is to 2. Ratio of speed is 2 is to 3 for car 1 to car 2. 2 is to 3 is ratio of speed, 60 is to 90 it has to be. And you can mark 90 as the answer, right? So a lot of what I said right now comes with practice. The more you practice mentally, right, you try to do it, you visualize a lot of, arithmetic and in fact logical reasoning as well, right? And in DILR, a lot of your logical reasoning cases at CAT level, you've got to visualize some way or the other, right? It's going to come in handy over here. So time and speed questions, once you master the ratios concept, right, or across arithmetic, you can start trying to do it mentally, at least the level 1 questions or level 1 or early level 2 questions. Yeah. At CAT level, can you do questions mentally? Definitely. At least half the questions in papers, you should be able to do it mentally. I don't recommend that to be done in the exam, but at a practice stage, you can try to do it. That will just broaden the way in which you think. Yeah. That's primarily it from this part. Okay. One of you wanted a repeat for the T-meet part. Okay. Okay, the meeting part, right? So the meeting part, we'll just go through this question once again. Yeah. Yeah, this question is okay. So no, okay, that's good. One of you didn't know how to solve it easily. Good. Okay, a straight road over here connects points A and B, right? So A and B over here are connected. Now car 1 is leaving from A, right? A to B, and car 2 over here is leaving from B towards A, and both are leaving at the same time, right? They start at the same time. After meeting each other, they take 45 minutes and 20 minutes respectively to complete their journeys. So the time taken, right, for meeting, right? So time taken for meeting is going to be what? Is going to be root of the product of the additional time taken after meeting. Additional time taken is 45 minutes by car 1, right, to complete the journey after meeting, and 20 minutes is the additional time taken by car 2 after meeting to complete the rest of the journey. So root of 45 into 20 is root of 900, and that comes to 30 minutes over here. Okay. So 30 minutes is what it takes to meet. Yeah. So if it takes 30 minutes to meet, what does that mean? Right. So what does that mean? So I'll just write down A and B over here. If car 1 is taking 30 minutes to meet, yeah. So 30 minutes to meet over here, looking at car 1, and then it's taking how much longer to reach B? It's given that it's taking 45 minutes longer to reach B. This is car 1 over here, 30 minutes to meet and then 45 minutes more. So the total time taken by car 1 is going to be what, right? So total time taken by car 1, that's going to be the time taken to meet of 30 minutes to the meeting point and then 45 minutes longer, total of 75 minutes. So car 2 likewise, the other way around, time taken to meet would have been 30 minutes, right? Because car 2 is coming from here. And after meeting in 30 minutes, it is taking how much longer? It's taking 20 minutes longer, right? That's what is given. So total time taken by car 2 is going to be 20 plus 30, which is 50 minutes. So the ratio of time taken is enough for us. 75 is to 50 is 3 is to 2. Immediately you can get ratio of speed over here, which is 2 is to 3. And car 1 speed is given as 60. If 2 parts is 60, right? 3 parts is going to be 90 kilometers per hour. And option 4 would be the answer. Yeah. Good. Okay. You understood it. Good. Yeah. Okay. So that's primarily it, right? With that, we come to the end of the session. We'll be having subsequent sessions with the master classes, right, for topics. So I hope at the end of this, you people have got a good hang of application of ratios when it comes to time and speed. I'm sure it wouldn't be like perfect, right? Because you haven't practiced enough. But as you practice questions, try to incorporate these concepts and do it. Yeah. Okay. Nice having you here, all of you. I'll see you people in the next session. Thanks.